Assalamualaikum. Welcome to my YouTube channel, and we have a second topic of differential equations, the course of MSc for engineering students, especially in maths students or engineering students. So differential equation, I have used book Daniel Diesel book. This topic taken from Daniel Diesel book. So we have topic special functions. So let's start. So in special functions, first we have Bessel equation. Understand that Bessel's equation of order V. So x square plus y double prime here, x square y double prime plus x y prime plus x square minus v square y is equal to 0. This is the Bessel equation where v greater than or equal to 0, here is v, and x is equal to 0, here x is equal to 0 is a regular singular point RSP of this equation. The solution of this equation are called Bessel function. Okay, note that this is remarkable points. Everybody ask me that what is the Bessel function. So here is the Bessel function. The solution of this equation, okay, are called Bessel function. Simple. So let's move next. Legendre's equation of order n. So Legendre's equation of order n. 1 minus x square y double prime and its coefficient minus y minus 2xy prime, x means first derivative, plus n plus 1 of y is equal to 0, where n is a non-negative integer and x is equal to 0 is an ordinary point of this equation. The solution of this equation are called Legendre's function. Let's see. Okay, so here is the Bessel's function of first kind. And special functions, we have Bessel functions of first kind and special functions. Okay, so we define that jv of x by jv of x is equal to, in compact form, summation n is equal to 0 to infinity minus 1's power n over n factorial gamma 1 plus v plus n's bracket over multiplied by this x over 2's power 2n plus 1. Okay, this is the Bessel function of first kind, and here is, if v is negative, then here j minus v of x is equal to summation n is equal to 0 to infinity minus 1's power n over n's factorial gamma 1 minus v plus n's multiply x by 2's power 2n minus v. Okay, in other words, the general solution of the equation, Bessel equation on 0 comma infinity is y is equal to c1 jv of x plus c2 jv negative v of x, v is not equal to any integer. Okay, here's the important thing. Okay, so here's the graph of j and y. So note that this graph, this values increases this type, and from these values increases this time, these lengths makes some special functions graphs, this wavelength and these wavelengths. Okay, so here is the Bessel functions of the second kind. Okay, Bessel function of the second kind. If v is not equal to integer, then y v of x is equal to cos v pi j v of x, negative j, negative sign here, and next j negative v of x our sin v pi, and the function j v of x are linearly independent. Another solution of Bessel equation is y is equal to c1 jv of x plus c2 jv of x. Okay, if v is not equal to integer, then j y v of x is equal to cos v pi j v of x negative j minus negative v of x over sin v pi, and the function j v of x are linearly independent. Okay, another solution of equation, Bessel equation. Previously we learned that first page. Notice that. So here I write 1 is y is equal to c1 j v of x plus c2 y v of x, as v imply m. Okay, v imply m in logical form. M an integer. The equation 10 has the form 0 by 0 from L'Hospital rule. L'Hospital rules. The function y m of x is equal to limit v imply m, v goes to m, y v of x and j v of x are linearly independent solution of x square y double prime plus x y prime plus x square minus m square y is equal to 0. Hence, for any value of v, the general solution of Bessel equation is y is equal to c1 j v of x plus c2 y v of x. Y v of x here, not that. Y v of x is called the Bessel function of the second kind of order v. Okay, and y naught of x and y of x from here. Okay, so here is the graph of these functions, and these graphs can make from this side, and these lines can make these graphs. Understand these graphs and your concepts so very well. Okay, here another equation is called the modified Bessel equation of order v. X square y double prime plus x y prime plus x square minus v square y is equal to 0. This is the Bessel equation of second kind. This is the first Bessel equation. We learned it on first page of this PPT presentation. This time we let t is equal to ix, then this equation becomes t squared second derivative d2 y derivative with respect to t d2y over dt square plus t is the time dy by dt plus t square minus v square y is equal to 0. The solution will be jvi of x and yvi of x, a real valued solution called modified Bessel function of the first kind of order v is defined by jv of x is equal to i's power negative v jvi of x. Okay, understand? Analog to 10. Okay, from the equation analog to 10, the modified Bessel function of the second kind of order v is not equal to integer is defined by kv of x pi I negative v of x minus I v of x. Okay, this is pi over 2 sin v pi. This is equation becomes 16 equation. And for any integer v is equal to n, k n of x is equal to limit v approaches to n kv of x, because I v and kv are linearly independent on 0 comma infinity. The general solution gs of 14 we learned previous page is y is equal to c1 I v of x plus c2 k v of x. Okay, we consider other important differential equation. Okay, pi double prime plus 1 minus 2a over x y prime plus b square c square x power 2c minus 2 plus a square minus b square c square over x square y is equal to 0. Now p, for the p greater than or equal to 0, this equation becomes 18 equation of our topic. The GS general solution of 18th equation, this equation is y here important. Y is equal to x power a bracket start c1 jpb x power c plus c2 ypb x power c bracket over. This form become equation 19. We shall not supply the details here. Note that we shall not supply the details here. Here are some properties of our functions. J negative m of x is equal to minus 1's power m j m of x. The second is here jm negative x is equal to jm of negative x is equal to minus 1's power m jm of x. Next, jm of 0 is equal to 0, m greater than 0, 1 m is equal to 0. Okay, this is the important property. The limit x approaches to 0 positive, ym of x is equal to negative infinity. Here are spherical Bessel functions. When the order v is half an odd number, that is plus minus 1 over 2, comma plus minus 3 over 2, comma plus minus 5 over 2 up to so on, the Bessel function of the first jv of x can be expressed as spherical Bessel functions. j1 over 2 of x is equal to summation compact form n is equal to 0 to infinity minus 1's power n factorial gamma 1 plus 1 over 2 plus n x power x by 2 multiple x power 2 plus 2n plus 1 over n 1 over 2. Since gamma 1 plus alpha is equal to alpha multiplied by gamma of alpha, and gamma 1 over 2 is equal to pi's power 1 over 2, then gamma 1 plus 1 over 2 plus n is equal to 2n plus 1's factorial. Then here is the denominators form 2's power 2n plus 1's n factorial, the multiple radical 2. This is important. Hence j1 over 2 of x is equal to summation n is equal to 0 to infinity minus 1's power n over 2n plus 1's factorial radical pi n factorial over 2n plus 1's n factorial x by 2 2n plus x by 2's power 2n plus 1's over 2 is equal to radical 2 over pi x summation minus 1 power n over 2n plus 1's factorial x power 2n plus 1, and j1 over 2 of x is equal to radical 2 over pi x sin x. This equation becomes 23. J minus 1 over 2 of x is equal to order radical 2 over pi x cos x. Here is the form of first kind of Bessel functions. Okay, so here are the very important things. Here is the solution of Legendre equation. Since x is equal to 0 is an ordinary point of equation 2, the first page of equation 2 is the Legendre equations. Okay, y is equal to summation n is equal to 0 to infinity c and x power n. After substituting this form and simplification, we obtain n of n plus 1 c naught plus 2 c2 is equal to 0, n minus 1 n plus 2 c1 plus 6 c3 is equal to 0, j plus 2 j plus 1 c j plus 2 plus n minus j n plus j plus 1 c j is equal to 0. This is a very simple solution of this form. If we simplify this form, then we get these simplifications or in the following forms. Okay, here the following forms, very important following forms. c2 is equal to n negative n of n plus 1 over 2 factorial c naught. c3 is equal to negative n minus 1 n plus 1 over 3 factorial c1. cj plus 2 is equal to negative n minus j n plus j plus 1 over j plus 2 j plus 1 cj comma j is equal to 2 comma 3 comma 4 up to so on. This equation, this recursive form become 25 equation. Using 25 at least mod x less than 1, we obtain j y1 of x is equal to c naught in this form, and this form become so on. And here y2 of x c1 in this form become so on. Notice if n is an even integer, the first series terminates, whereas y2 is an infinite series. If n is an odd integer, the series y2 terminates with x power n. So we have the Legendre polynomials. The following are nth order Legendre polynomials. P naught of x is equal to 1, p1 of x is equal to x, p2 of x is equal to 1 over 2 3 power 3x power 2 minus 1 and p3 of x is equal to 1 over 2 bracket start 5x power 3 bracket over minus 3x. This equation becomes 27th equation. p4 of x is equal to 1 over 8 35x power 4 minus 3 30x power 2 plus 3 bracket over p5 bracket start x bracket over multiply x 1 over 2 is equal to 1 over 8 63x power 5 minus 70x power 3 plus 15x bracket over. Okay, this is the our Legendre's polynomials. This is the graph. Okay, this is the very important graph of the Legendre's polynomial. This graph become this line and this curve start these lines. Here is p0 graph and p1's graph is here. Okay, and this values become the increase in this series and these values increase in this series. Okay, this is the x-axis, this is the y-axis, and these are the graphs of this function. Okay, and here are the some properties. Pn of negative x is equal to minus n's power n and Pn of x, and the second is Pn of 1 is equal to 1, and third is Pn of negative 1 is equal to negative 1's power n, and Pn of 0 is equal to 0 and odd. N is in odd. Okay, and 5 is P dash n of 0 is equal to 0 where n is in even. This is a remarkable point. And here is the recurrent solution without proof. We have k plus 1 pk plus 1 of x minus 2k plus 1x pk of x plus k pk minus 1 of x is equal to 0. This equation we have a 29 equation which is valid for k is equal to 1 to 3 up to so on. Another formula by differentiation to generate Legendre's polynomials is called the Ordinary formula. Okay, Pn of x is equal to 1 over 2 power n factorial d power n over dx power n x square minus 1 power n comma n is equal to 0 comma 1 comma 2 up to so on. This equation becomes 13 equation. Okay, so I hope that you learned very well of special functions and Bessel equation, Legendre equations. Thank you for watching my video. So I request you that please subscribe my channel, that I will motivate and I will make another video. Okay, thanks.